Hello and welcome. We are going to look at curve fitting equations today. This is lesson 6-2. So starting out, we're going to do a couple of the ones that you're already familiar with. That is curve fitting with exponential functions. So our goal here is to find the equation, of the exponential function that passes through the following points. So in other words, we're given a couple points here, and we want to know what is the equation of that function that passes through those 2 points. So to start out here, the first one, we're going to look at using the substitution method. Okay, so the first one, we're looking at substitution. We're going to take our y equals a times b to the power of x, and we need to figure out what a is and what b is. So since we have 2 variables that we're going to be solving for, we're going to need 2 equations. So we're going to take our x and our y from each of our points. Okay, so we're going to take those numbers and substitute them in for the x or the y value, depending on which one it is. So let's start out here with the point 216. I'm going to put 16 equals a times b to the power of 2. So 16 was my y, 2 was my x, and you see it's now in the equation. The second one, we're going to do 256 is equal to a times b to the power of 6. I apologize if my b's and 6's look a lot alike there, but I'll do my best to make sure you can see which one's which. All right, now we look at this one here. I'm going to start out with my 16 equals a times b to the second power, and my goal here is to get a by itself. So I'm going to divide each side by b squared. So I'm looking at here 16 divided by b squared equals a. And because we're using substitution there, we know that we could take this a right here and we can substitute whatever it equals into the other equation for that a. Let's do it. So 256 equals, instead of a, we're going to put 16 over b squared times b to the 6th power. Now, if you're one who likes to simplify here, I'll go ahead and multiply the 2 fractions there. So we have 256 equals 16 b to the 6th power over a b squared, if you're more comfortable seeing it that way. Now we just need to simplify and solve. So since we have b to the 6th over b squared, that will just become a b to the 4th. So we have 256 equals 16b to the 4th power. Now you know how to solve these here, so this should be 16 equals b to the 4th. You're going to need to take the 4th root of each side there, and when you do, you're going to end up with b equals 2. And just like with any other system of equations, you're going to take that b equals 2 and substitute it into one of the original equations and solve for the other variable. So we've got now 16 equals a times, instead of b, we're going to put 2 in there, and it's being squared. So we now have 4a equals 16. We divide each side by 4, and you're going to get that a equals 4. Now that we know both those values, remember that's not the answer. The answer is going to be in the form of an equation. We're going to plug them into the equation to get that answer. So y equals, a has to come first, so we have 4 times our 2 to the power of x. And that is the answer to this first example. Now, how can we check it? You can always take your x and y values and plug them into this equation and make sure that they make true statements. A second option, which I'd love to show you, but I don't have the ability to do that on my iPad, is to graph the function and then look at a table to make sure that those 2 points exist on the table. All right, let's do the second example now here. We've got y equals a times b to the power of x. If you want to pause it and work through it using substitution to make sure that you understand it, that's totally fine. I'm actually going to use the elimination method on this one. Okay, I'm going to use the elimination method. So I'm going to use a slightly different method, which is probably a little bit quicker if you do it the right way. But, you use whatever you prefer. So first step again, let's go ahead and create our system of equations. We should have 4 equals a times b to the third power, and 36 equals a times b to the fifth power. All right, now we're on the right track. So when we go through and we look to do this one here, I'm going to use what I call, and I don't even know if this is the official name of it or not, but I call it elimination. Okay, so when we do elimination with linear equations, you add them in order to get one of the variables to cancel out. Here, because we're dealing with multiplication and division, we want to divide the two equations in order to make one of the variables cancel out. All right, so we're going to take the equation on the right that has the greater exponent, and we're going to divide it by the equation on the left that has the lesser exponent for b. So here's what it looks like. We're going to take it and we're going to do divided by 4 equals a b to the third. Now what's really happening here is if I do 36 divided by 4, I get 9. A divided by a is 1, so that's the elimination part of it. The a's are kind of canceling out there. And then b to the fifth divided by b to the third gives me just a b squared. So 9 equals b squared. That's easy to solve then. We're going to end up with b is going to equal 3 in this case. So we're going to take that value and let's take it and let's put it into that first equation and solve for a. So 4 equals a times 3 to the third. Please don't make the mistake of raising 3 to the third and getting 9 because it's 27. So 27a equals 4. So then a equals 4 27ths. I know, weird fraction, right? That must mean it's wrong. Nope, it's correct. Okay, sometimes you get numbers that just aren't real pretty. So our function that passes through the point 3, 4, and 5, 36 is going to end up being y equals 4 27ths times 3 to the power of x. To check it, you can plug in those 2 points, or again, you may graph it and then look at the table to make sure that those 2 points show up. All right, so we're going to move on here. Those were problems that you've probably already done, maybe not in those methods there, but you should be familiar with what curve fitting is now, or you should remember. The next part we're going to do is going to involve quadratics. So let's just do a quick review of quadratics. There are 2 different forms of it that we've used this year. The standard form, whoops, I didn't mean to do that. The standard form is on the left, and the graphing form is on the right. Now I've created a list of things here that we've used it for and some important characteristics for each of them there. Rather than go through and explain all of them there, you can pause the video and write them down. Okay, I want to save some time here, so go ahead and pause it, read through it. If you have questions, you can ask about those tomorrow, but go ahead and do that there. And then I'm going to go ahead and actually move into the next problems. This is problem 6-61. It says, suppose the graph of a quadratic function passes through the points 1, 0, 2, 5, and 3, 12. Sketch its graph, then work with your team to develop an algebraic method to find the equation. So we're going to look for the equation here in standard form. That's what we're focused on here with this problem. So it goes to the point 1, 0, 2, 5, and 3, 12. You see I've already plotted those points. If I was to sketch that parabola, it would probably do something like this. It would probably come down and go somewhere up here. I don't know exactly where at the moment, but I do know, because this is the way it looks, that A is going to have to be positive. C is going to have to probably be a negative, right? Because our y-intercept is down below here. A being positive because it opens up. So we're going to take this and solve this. We're going to have to find the values of A, B, and C. So since we have three variables, we're going to need to have three equations. So now you understand why we've been practicing solving systems with three variables here. We're going to take this here, and to create our first equation, we're going to do exactly what we did with the exponentials. We're going to take these values of x and y and plug them into the equations. We're going to set up an equation for each of the 3 points that we've been given. So here we go. The first one, our y-coordinate is 0, so we're going to have 0 equals a times 1 to the second power. So we just put in the y for y, we put in the x for x, plus b times 1 plus c. It's as easy as that. So the second one, let's plug in 5 for y. We don't know what a is, so it stays as a. We have 2 squared plus b times 2 plus c. The third one, we have 12 equals a times 3 squared plus b times 3 plus c. So we've created our three equations there. Now let's simplify them, and you'll see why we're doing it the way we're doing it here. So I'm going to rewrite them to the right side. So I'm going to start out with the right side of the equation and simplify it. So 1 squared is 1 times a is a, plus b times 1, which is b, plus c equals 0. The second equation, we do 2 squared, which is 4. So we have 4a plus 2b plus c equals 5. And then the third equation, we're going to have 9a plus 3b plus c equals 12. We've got this equation now, or we've got three equations, and hopefully this looks familiar to you because this is what we've been doing for the past couple days. So instead of labeling my equations here as just, A, B, and C, because I'm using A's, B's, and C's, I'm just going to label them as like equation 1, equation 2, and equation 3. When you look for a variable to eliminate, if you look closely here, all of the C's have the same coefficient, which is going to make it much easier to start doing elimination there. So if it's up to me, I would say go with C first. Let's go ahead and do that here. We've got, I'm going to do -1 times equation 1. And please feel free to pause it, solve it, then fast forward to see if you're right or wrong. I would actually prefer if you try to do that here. That'd be good practice with these kinds of problems. We should have a -a minus b minus c equals 0. And then let's do, equation 2 with it. That sounds good to me. 4a plus 2b plus c equals 5. And we add them together, we're going to get 3a plus b equals 5. We'll call that equation 4. Now you just need to pick a second pair of equations and eliminate the same variable. So you can do any one you want. I'm going to do, I'm going to do 2 and 3 on this one. So I'm going to say -1 times equation 2, and I'm going to do equation 3. So if I distribute a negative through equation 2, I'm going to have a -4a minus 2b minus c equals -5. And equation 3 we know is 9a plus 3b plus c equals 12. Let's add them together. We've got 5a plus b equals 7. So now let's just solve. This looks like it's going to set up pretty easily for elimination. We have a b in each of them there. So I'm going to multiply equation 4 by negative 1. And we have negative 3a minus b equals negative 5, which leaves us with 2a equals 2, so a has to equal 1. Take 1, substitute it back in. I'm going to put it into equation 4. So we have 3 times 1 plus b equals 5. And b ends up equaling 2. Then last step, plug them both in to one of the original equations to solve for c. So we're going to say here, let's plug it into a plus b plus c equals 0. So 1 plus 2 plus c equals 0. So c equals negative 3. Final step here, before checking it, would be to write it out. Y equals, now instead of writing 1x squared, okay, we can write x squared. We know the coefficient is 1, plus 2x minus 3. And this should make sense because we needed our a value to be positive and we needed our c value to be negative, and they are in both of those. Okay, so that makes sense with that. But to check it, you can either plug in the 3 points into the equation, or you can take it, graph it, and make sure it's on the table. All right, checking is important here, but so is your time, and that's why I'm trying to get through this as quickly as I can. All right, so let's move on to the last problem here. If you want to pause it and try it, I would welcome that. I would say that would be a good idea to at least see if you can set up the equations on your own here. So if you want to hit pause right now, and then you can check to see if you get the same thing that I do. Here we go. I'm going to take it and plug in my points. So starting out with the point 310, I have 10 equals a times 3 squared plus b times 3 plus c. I've got 36 equals a times 5 squared plus b times 5 plus c. And the last one, 15 equals a times negative 2 squared plus b times negative 2 plus c. And we're going to do this simplifying now. So make sure you're careful, please, when you are simplifying. You should get 9a plus 3b plus c equals 10. You should end up with 25a plus 5b plus c equals 36. And the last one, 4a minus 2b plus c is equal to 15. Be very careful with that third one there, because that negative 2b, and also when you square the negative 2, you should have a positive 4. Very easy mistakes to make. So we're going to just label our equations here so we know what we're dealing with. This is equation 1, equation 2, and equation 3. Now choose 2 pairs of them and probably eliminate the same variable. Again, c is going to be the easiest one to eliminate. So I'm going to do negative 1 times equation 1, which would be negative 9a minus 3b minus c equals negative 10. And I'll do that one with equation 2. It's 25a plus 5b plus c equals 36. And when we eliminate, we should have a 16a plus 2b equals 26. We'll call that equation 4. The second pair is up to you, whichever ones you want. I'm going to do, let's see, I'll do 1 and 3 on this one. So I'm going to multiply equation 1 times a negative just to keep it consistent. You can use whatever you want. Don't feel like you have to use what I use. Now do your elimination step. You should get negative 5a minus 5b is equal to 5. We'll call that equation 5. Now you got to figure out a way to eliminate between 4 and 5. Okay. Nice thing about equation 5 is they're all 5s. So we know that this is divisible by 5. And if I divide everything by 5 here, I would have 1s for my coefficients. Then I could easily multiply it by 2. So let me show you here. If I do, and you can do this, whoops, I hit the wrong button there. You could do 1/5 times equation 5 and get negative a minus b equals 1. And then if you multiplied it by 2, you'd have negative 2a minus 2b is equal to 2. So you just divided by 5 and multiplied by 2, which is the same thing as just multiplying it by 2/5. So I've multiplied equation 5 by 2/5, and I ended up with negative 2a minus 2b equals 2. Eliminate there, you're going to get 28 equals 14a. So a equals 2. Take that, plug it back into one of the equations here to figure out what your b value is. So I'll just do that right here. I got a little bit of space left. So 16 times 2 plus 2b equals 26. That's 32 plus 2b. So 2b equals negative 6 after you subtract. And b would equal negative 3. Last step, plug both of those into one of the original equations to find what c is. So 9 times 2 plus 3 times negative 3 plus c equals 10. So it should be 18 minus 9 plus c equals 10, which is 9 plus c equals 10. So c has to equal 1. And now let's put it all together. Y equals 2x squared minus 3x plus 1. And if you graph it on the calculator and look at the table, that will be those points will exist, or if you plug in each of those points, it should make it true. All right, that's the last example. Hopefully this has helped. If you have questions, please mark where you have questions at, and we will discuss in class. Thanks for watching. Please enjoy the rest of your day.